Hello, this is Python versus R from Conwell Consulting, and today we are going to discuss polynomial regression and Python versus R. Polynomial regression is a part of linear regression in which the relationship between the independent variable x and dependent variable y is modeled as an nth degree polynomial. There are various real-world applications such as dependency analysis and advanced analytics in the field of medical to gauge the progression of disease epidemics, and in the chemical industry to determine the distribution of carbon isotopes. Polynomial regression is used for statistical analysis of growth rate and its correlating factor. So now let's move to the demo, and we're gonna go and compare Python versus R in the live code demo. So this is Python's code, and first we're gonna start Python, and then we're gonna do R. So first we're gonna start by importing the libraries. Then we're gonna import the statistics models. Then we're gonna load the dataset. And then we're gonna load the polynomial regression libraries. And then we're gonna test the dataset. Then we're gonna train the dataset to 4 polynomial variable levels. Then we're gonna convert our dataset to polynomial regression in 3D. And then we're gonna visualize our polynomial regression. So this is a 3D visualization from Python in polynomial regression. Now let's start over with R. It's the same process. We're going to load our dataset. Then we're going to test the dataset. Then we're going to train the dataset with 4 polynomial degree, just like we did in Python. As you can see that R requires various levels of training the data in the 4 degrees, where Python could generate it automatically. So we're gonna go and do it level by level. And finally, we're going to visualize the polynomial regression in 3D. So it's going to load the required packages. In R, the packages plays a main role for visualization, whereas in Python, it automatically detects and shows and the results. So this is R's visualization. It's a 3-dimensional model which fully scalable and easy to read the polynomial regression and the correlation between the x, y, and z. Where R's visualization is very appealing, but the process is very lengthy and requires hardcore skills, which can be very good and useful in the field of academics and statistics, where Python does not have a very appealing visualization chart, but it's useful and it's very easy to code. So let's move to the scorecard. For code volume and ease of use, Python gets 4 because Python's code is less for its functionality, but readability is a little bit complex, where R has a lengthier code, but readability is simpler because it's defined in levels. For popularity and library availability, Python is better for beginners, where R has more traditional clienteles. For execution and performance output, Python has an upper hand in the clarity and execution time. R takes a lot of time in loading the library. And for scalability and transferability, Python and R both offer same flexibility and scalability, and they are both customizable depending on the user's needs. And for training and support, both Python or R have a broad community support and user libraries for various tutorials. For the final score, Python gets 4.7 and R gets 3.9. For polynomial regression, Python is very adaptable and effective to give a concrete result, whereas R's capability get limited by the complexity of the code and loading time of the libraries. So this is the final verdict. Python is simpler to use and offers a user-friendly environment. It is a perfect language for users with no coding background. Thank you.